Hey, I'm Courtney Waterman, your tutor. Lover of anime, manga, and math. And you just tuned into another session of Tutor Me Sempai. Welcome back, everyone. Today we're jumping into an 11th grade topic, finding reference angles from negative angles. Now, if you're new to my channel, I'll be putting timecodes in for this video in the description box below, so use that to skip ahead to whatever part of the video you think is most interesting. As always, if you have any questions about what we see today, or if you want homework, you can always put in the comment box below, or visit my Facebook page, @Tutor Me Sempai, and tell me all about it there. At the end of this video, I'll be linking my 11th grade playlist, in which I cover a lot more topics, so if you're interested in that, make sure you stay tuned. This video is going to have 5 parts, however that last part is going to be a bonus part just for you, in which I cover something that's kind of similar, but not directly related to negative angles, so you're not going to want to miss that. Therefore, make sure you stay tuned, hit the like, smash subscribe, and let's get started! In an earlier video, we covered reference angles, and if you recall, in that video, we only mainly focused on angles that were between 0 and 360 degrees if you were in degrees, or 0 and 2 pi if you were in radians. Those are the angles we use in order to find our reference angles. But what happens if we try to find a reference angle of a negative angle? Well, considering I've already talked about reference angles in that previous video, I'm not going to redefine what a reference angle is. However, if you need a refresher, make sure you check out my previous video on that. You can find it right up here, and come back to this one so we can see how we're going to find reference angles of negative angles. However, I'm not going to leave you high and dry. I will remind you of 3 things that we talked about in that video. The first is going to be the 4 formulas we use to find our reference angles depending on which quadrant we were in. You can make these same 4 formulas if you're in radians. So these are the 4 formulas we talked about in that previous video. The second thing I want to remind you of is that reference angles have to be positive. And the third thing I want you to remind you of is reference angles have to be acute. That means they have to be less than 90 degrees. They have to be a very small angle, less than 90 degrees. Now, if you take these 3 things that I remind you about and put them all together, you will quickly see why we can't simply plug in our negative thetas into these formulas to find our reference angles. But if it isn't too obvious, no worries. Let's take our very first one, our easiest formula, and see why this quickly breaks down when we have negative angles. Assuming we start with a negative angle, negative 330 degrees. So we start here and go all the way around, and that's going to end up right around here. And this is going to be negative, put it right here, negative 330 degrees. Clearly, we're going to be in quadrant 1. That means that we would just plug this into our formula, and that's going to be our reference angle. And if we were to do that, our reference angle would be negative 330 degrees. However, this breaks something, right? We said it had to be positive and acute. Now, yes, it's small, definitely less than 90 degrees, but it's not positive. So if we had to be positive and acute, we have to be somewhere between 0 and 90 degrees since we're in degrees. This is not it. Therefore, we can't just simply plug in our negative values into our formulas. We need to do something else. But what is that something else? What step are we missing here? Our missing step is that we're going to have to rely on something called a coterminal angle. Now, I already have a video on this topic, and if you want, you can check it out right up here. If you understand what a coterminal angle is, you will see why it is very important in what we're trying to do right now and trying to find these reference angles of negative angles. It is crucial. You can't do it without it. So make sure you understand what coterminal angles are and then come back to this video so we can see how we can use that to find these reference angles. But assuming you have a good understanding of coterminal angles, let's see how it's going to be helpful for our previous example. Now remember, we had negative 330 degrees, somewhere around here. Negative 330 degrees. We said we can't plug that into our formula. Well, we want to find a coterminal angle for this angle here. Well, it's negative 330 degrees. Now, this is going to be true for radians or degrees. Don't get caught up on that. I'm just focusing on degrees for this example. So we have negative 330 degrees. In order to find a coterminal angle, we want to either subtract or add 360 degrees. Well, we don't want just any coterminal angle for this to work. It has to be a coterminal angle between 0 and 360 degrees. So we want to make it one positive. We don't want to subtract anything because we want to get more negative, and that's not going to help us. So we're going to keep adding 360 degrees however many times it takes in order for us to land between 0 and 360 degrees. Luckily, it only takes one time for us to get there, and when we add 360 degrees, we're going to get a positive 30 degrees. That lands us right where we need in that sweet spot of between 0 and 360 degrees. So once we have a coterminal angle between 0 and 360 degrees, we're then going to take that theta CT, and instead of plugging in our original theta, we're going to plug in our theta CT. So instead of plugging in our negative 330 degrees into our formula, we're actually going to be plugging in this positive 30 degrees. And when we do that, we realize that this is actually going to be our reference angle. Since we're in quadrant 1, our angle is going to be the same as our reference angle. And if we do our little check on the side, you see that it is definitely positive and it is definitely acute. So this is going to be how we're going to find our reference angles when we have negative thetas. First, you're going to use your coterminal angles to find something between 0 and 360 degrees, and then plug that into the corresponding formula you need, depending on which quadrant you're in. But let's look at a few examples to drive this point home. So here we have two examples. We have an example in degrees and we have an example in radians. And notice that they're both negative thetas. We want to find our reference angles. However, remember, we can't just plug this in. We have to do what? First, we're going to find coterminal angles between 0 and 360 degrees for our degrees, and 0 and 2 pi for our radians. So let's start with number 1. We have negative 505 degrees, and we want to find something between 0 and 360 degrees. That's the very first thing we have to do. So we find our coterminal angle. And to do that, because we're negative, we have to get more positive. So we're going to keep adding 360 degrees until we get what we're looking for. Now when we add it here, we're going to get what? This is going to be negative 505 plus 360 degrees. If we do that, we're going to have negative 145 degrees. Are we there yet? No. Well, that was our very first coterminal angle. Let's find another one. So this is going to be coterminal 2. We're going to start with negative 145 degrees and add another 360 degrees. When we do that, what are we going to get? Well, we should get 215 degrees. Is this between 0 and 360 degrees? Yes. Perfect. Now that we know which coterminal angle we want to use, we have to figure out which quadrant is this going to be in, because we have to figure out which formula we're going to need. Well, 215 degrees is going to be in our third quadrant. Well, the formula for the reference angle in our third quadrant is going to be as follows. So Q3 is going to be our reference angle, 3, equals our angle minus 180 degrees. But which angle are we going to put into this one? Are we going to put in negative 505 or this 215? We're going to put in our 215 because this is a negative angle. We're going to actually, instead of just theta, we're going to do theta CT, our coterminal angle. And when we do that, we're going to get 215 degrees minus 180 degrees. Well, what do you get when you subtract both of these? Well, this is going to give us a 35-degree angle. So our reference angle for our third quadrant is going to be 35 degrees. Let's move on to our second example. Here we have negative 21 pi over 4. We're going to do the same thing. We have to find our coterminal angle that's going to be between 0 and 2 pi before we can start plugging in anything. So let's start first. Our coterminal angle is going to start with this, is negative 21 pi over 4, and we're going to add 2 pi. But we need it to be in fraction form, so instead of adding 2 pi directly, we're going to add 8 over 4 pi. Or in other words, 8 pi over 4. When we add this, we're going to get a negative 13 pi over 4. Is that what we want? No. So we're going to keep going. That was our first coterminal angle. Let's find our second one. We're going to start with this negative 13 pi over 4. We're going to add another 8 pi over 4. And what do we get when we do that? This is going to result in a negative 5 pi over 4. Are we there yet? No. we're going to keep going. Remember, you want to have something between 0 and 2 pi when you're in radians. Well, since we no longer care about our first one, let's erase that because we're running out of space here. We're going to erase that, and we're going to take this and move it up here. So our coterminal angle 3 is going to start with negative 5 pi over 4, adding 8 pi over 4. And what do we get when we do that? Well, this is going to be a 3 pi over 4. Now, is this between 0 and 2 pi? Yes. So we can technically stop there. Our coterminal angle is going to be 3 pi over 4. That's the thing that we're going to move forward with. Coterminal, 3 pi over 4. Now we have to determine which quadrant does this live in. Well, this is going to live in our Q2. And the formula for that is going to be 180 degrees if you're in degrees, or it's going to be pi minus your theta. Pi minus your theta. But in this case, we don't want to plug in our negative theta. We're going to plug in this positive one, our theta CT, our coterminal angle. And when we do that, we're going to have pi minus 3 pi over 4, which is going to result in a 4 over 4 pi, because we have to make it into our fraction. And this is going to net us with a whopping pi over 4. Is this between 0 and pi over 2? 0 and pi over 2. Yes, this is going to be right there in the middle between 0 and pi over 2. That means it's an acute angle. We already know it's positive. It's going to be an acute angle. Same thing for this. We see it's positive. We see it's less than 90 degrees. It's an acute angle. Both of our reference angles are going to be correct in this situation. This is our reference angle 2. Now, if you stuck with me this far, you're a true champ, and I hope you appreciate this bonus I'm about to give you. Although not directly tied to our negative thetas, it is going to be related to what we're doing now, because our negative thetas aren't going to be the only thetas that fail when we plug it into our 4 formulas. Another type of theta that will fail is going to be a theta that's entirely too big, something bigger than 360 degrees. So let's say we have a theta that's 690 degrees. If you were to find out what quadrant this is in and then plug it into that corresponding formula, it will fail just like you did for your negative thetas. You could get a reference angle that's entirely too big, or you could get something that's entirely too negative. So the remedy for this is we're going to do this in reverse of what we've been doing. When we had negative thetas, we added a bunch of 360 degrees or a bunch of 2 pi's to get us where we need to be, between 0 and 360 degrees or 0 and 2 pi. However, if we're too positive, if we're too big, we're going to subtract 360 degrees or subtract 2 pi until we're back in that same range. So instead of plugging this directly in, let's subtract 360 degrees until we find our sweet spot. So we're going to subtract this. So our CT is going to be 690 degrees minus, this time, 360 degrees. And when we do that, we're going to get 330 degrees. Is this between 0 and 360? Yes. So that means our coterminal angle is going to be 330 degrees. And this is going to be in quadrant 4, which means our Q4 formula is going to be theta R4 equals 360 degrees minus our theta. However, we're not going to plug in our original theta. That's entirely too big. You can see how that's going to immediately fail. We're going to have a negative theta. It can't be a negative for our reference angle. But when we plug in our coterminal angle instead of our original angle, we're going to get 330 degrees here, and this is going to result in 30 degrees for our reference angle, which is both positive and acute. So instead of adding a bunch of 360 degrees or 2 pi's, we're going to keep subtracting until we find that sweet spot. Remember, we always want to find an angle between 0 and 360 degrees, or 0 and 2 pi. Well, I hope you were able to follow along with today's examples, and I hope you stood around for that bonus. However, if you have any questions about what we saw today, or even your own homework, you can always put in the comment box below, or visit my Facebook page @Tutor Me Sempai and tell me all about it there. If you hadn't done so already, remember to leave that like It really helps the channel by letting YouTube know that you found the video helpful. And if you found the video helpful, so can someone else. So leave a like, hit the notification bell, smash the subscribe button, and share this video with a friend. Well, that's all the time I have for today. I really hope it's helped with your homework. I'm looking forward to seeing you again next week. I'm Courtney, this is your playlist, and this has been another session of Tutor Me Sempai.